Now, the last type of the partial differential equation is hyperbolic equation. So what is a hyperbolic equation? Hyperbolic equation, right, it depends on the u is a wave, okay, and depends on the space x and y. Right, we can also depends on time, but the condition is del squared u over del x squared minus del squared u over del y squared equal to 0. Right, or you can write as a del squared u over del x squared equal to del squared u over del y squared. So now this is a pattern, this is a type we call as hyperbolic equation of partial differential equation. The question here is how to use finite difference method to discretize, to derive, okay, to make it in Greek form, okay, from the equation, from the second order derivative, right? So now we learn in chapter 5 about numerical differentiation. Okay, for second order derivative, u respect to x, okay, we can write as a ui minus 1 minus u2 ui plus 1 divided by delta x equal to u, because this one is respect to y, j minus 1 minus 2 uj plus uj plus 1. Alright, so now we can put j on the right hand side, okay, and then I to the left hand side we put j, to right hand side we put I. Alright, so you put I because this is not related derivative respect to x. Right, so it's very simple. Okay, as elliptic and hyperbolic and parabolic, okay, you can rearrange this equation, okay, into two parts. Okay, but before that, make it more simple by times delta y for both parts. Okay, you can get delta y over delta x squared equal to lambda. So you can get lambda ui minus 1j minus 2 uij plus 1j equal to, right, ui minus 1j minus 2 uij plus uij plus 1. Alright, so you have two parts here. Okay, alright, you bring ui minus 1 and j minus 1 and j to the left hand side. You arrange, okay, the condition as a uij plus 1, okay, uij plus 1, okay, one side, okay, the new grade for at y direction is equal to lambda ui minus 1j plus 2 ui minus 1j uij, okay, minus 1 minus lambda uij plus lambda ui plus 1j minus uij minus 1. Okay, so this one. Alright, so how many points involved here? 1, 2, 3, 4, 5, 5. How many times that? Or how many y direction involved here? 3 direction. Where the direction? ui plus 1, j plus 1, j minus 1, I minus 1, I plus 1. So what is the point? The point is a 5-point derivative. Alright, the grid is number 1, number 2, number 3, number 4, okay, and number 5. So this is the grid number 1, uij plus 1, the first one. The grid number 2, ui minus 1j. Grid number 3, uij, and then grid number 4, ui plus 1j. The last is uij minus 1. Right? So this is the way how we write the computational tool and the basic to solve